Our next speaker will be Mr. Simon Carr. Simon has 20 years experience as a consultant in the development and solutions delivery in the improvement and components and for the company's performance, sorry. He has a wide range of areas, not only manufacturing, but also service areas. So, and he's the general manager of SMMT Industry Forum Limited. Hello, Simon. Can you hear me?
Yes, I can hear you. Sorry, just turning on the technology.
How are you? I'm
great, thank you. How are you?
It's been a long time since we see us, a year at least.
I know. Yeah. What a year.
Yeah, what a year, yes.
Yeah.
Exactly. Yeah. So with no more delays, I'll pass the word to you for your presentation, and then we'll have some answers at the end of your speech.
Okay? Excellent. Thank you very much.
Okay.
Okay, just minimize that. Okay, well, good afternoon, everybody. What we're going to be talking about just for the next half hour or so is really some of the approaches around operational excellence. So I'm going to talk a little bit about lean, a little bit about total productive maintenance, but then also to stress that this relies on a solid foundation. So we're going to talk about some of those elements, and then we'll just finish up with where you can get some more information if you require. Just scroll down. Okay. Not paging down for me. Click on the presentation. There we go. Okay, thank you. Hopefully it will be good. Right, so just to set the scene, sorry about that, just to set the scene, when we think about lean, TPM, all of these things, there are different approaches. Ultimately, we were trying to transform the business in some way. It's not making small little shuffles here and there. Really, these approaches can truly transform the operation. And this image is just trying to show conceptually, regardless of approach, what you're trying to do. And the story, of course, begins with current state. So it's important to get a very clear understanding of the current state, the performance, the challenges. And this way, we're very clear that we solve the right problem. We can spend a lot of time and energy in solving things that are actually not the real problem. So clear understanding of current state is the starting point. And you could just move straight from there to future state. But what is more helpful is to have a degree of creativity. So there are techniques around this concept of ideal state that allow us to think more freely, get some creative ideas. And it means that as we do develop a future state, whether it's for the next year or the next handful of years, we're including creative ideas, not simply removing the problems of today. And all of that thought goes into a future state, ultimately building an implementation plan, and then that will drive who is doing what and when over the coming months and possibly years. So when we think about lean has been around for decades now, originating as Toyota Production System, of course, and then Womack and Jones doing a good job to sort of clarify, if you like, the essence of what this is trying to achieve. So they, in one of their publications, Lean Thinking there, they described the implementation of lean as a series of steps. And this really begins with understanding value, and we'll explain each of these in a little bit more detail. Understanding the value stream, and then doing something about it. So seeking to create flow, then moving to pull systems as opposed to push, And then once we've got that stable situation, it's really then about continuous improvement or seeking perfection. So when we think about value, of course, we have to look at this in terms of what the customer perceives as value. What do they truly require? And not only what do they require, but what do they require in terms of service? So what is the timeliness, and what's also the price that they expect in order to satisfy their needs? And the needs of the customer can be articulated in three ways. And if we move to the next slide, we have something called the Carr model. So the Carr model is considering the service we offer and whether it meets the customer's perception of value. And there are some things described as the basic needs. This is the red line on the bottom. These are things that are taken for granted. You know, if we think of something like the humble mobile phone, now smartphones, all of these features you have on your phone are taken as standard. You don't even specify them. And the key point with the basic needs is if they are in some way failing, then this causes frustration and annoyance with the customer. So the basics are taken for granted, they have to be met. And whatever our product or service, there will be these basic needs. Next, there are some that are specifiable. So if we use again the phone as an example, now there may be a whole choice of the different cameras that you may have on your phone. The point being that as a customer, you can specify. You can choose to pay less or choose to pay more, depending on the specification you desire. But then the third one becomes interesting. So these are the things that delight the customer. Didn't even think it was a problem, didn't even expect it would be a solution. And those are the things that can differentiate suppliers by being able to solve those problems that the customer hadn't even thought possible. Now, there is one caveat with this model and one fact of life, that what are today's delighters will become tomorrow's performers, and then over time they will become basic needs. So this idea of understanding value is a constant living thing. We have to constantly challenge ourselves to really understand value in the eyes of the customer, and then we can develop solutions that meet those requirements effectively. So the next consideration is about understanding the value stream. And again, it's been around for a while as a technique, understanding value stream mapping. So used to being materials and informations flow, because that's pretty much what it maps. So we begin with a clear indication of what the material or the physical flow is, and that's starting from suppliers over to customers and every step in between. And we're also trying to understand in that flow where the inventory sits, because inventory, although necessary, can sometimes be something of a curse. So understanding the physical flow, then understanding the information flows. So what are the triggers for demand? What are the triggers for action? Are they electronic? Are they physical? Are they paper-based? Understanding all of those information flows that allow things to happen from beginning to end of the process. And then when we have all this, we can then summarize the time it takes. So this is an important indication. We know exactly from studying the value stream, we know exactly how long it takes us to satisfy the customer. And then, you know, if the customer requires flexibility, this also tells us whether or not we can truly be flexible. So this is a good way to understand the process. We use this to understand the current state. It works for physical processes, transactional processes, just slight variation in how you map it. But it's a very good way to get one big picture view of how things work currently. And you'd use this to identify all of the problems and concerns. And then you start to build that future state. And just using this simple example, there may be a number of strategic options available to you. So it may be a situation where you make to stock, the value of the stock may be not too significant, or that stock may be the best way to protect you from fluctuations in customer demand. So when you're in a make to stock situation in your value stream, you can see that the point that you're actually scheduling, if you will, with the XOXO indication there, is at the end of the process. So when you make to stock, what you're really identifying is what is the gap in the shelf, and then what do I need to fill that gap? That applies to the end of the process, as we can see by the arrow there, and that sends a signal right back through the internal supply chain, process by process, and even up to raw material supply. And it's that pull signal. We talk about supermarkets, so you have this repeated gap on the shelf as you go upstream in the process, and it's replenishing that, which is the production signal. And if we can achieve that signal, it will control the amount of inventory. That in itself reduces cost, risk of obsolescence, quality problems. And it also means that our lead time is set and will be reduced compared to current state. Another alternative approach is assemble to order. So we may not need to hold stock that of finished goods. That can save time and cost. So when we make to stock, when we make to order, assemble to order, it is that assembly process that's the point in the process that's scheduled. That will lead to a first in, first out on the shelf available for customers. And similar to before, it will set a pull signal up through to replenish the sub-processes upstream, right back through to raw materials that you require. And then thirdly, considering make to order. So this will be situations where it's not clear exactly what the customer requires. So we want to make to order, so we mitigate risk. In that situation, we want the following process steps to be quick and as efficient as possible to minimize impact on lead time. And in this case, we basically schedule in the front of the process. That will lead to a first in, first out downstream, and it will still create the pull for raw materials upstream. So the whole idea with these different situations is you're trying to create a closed loop where inventory, processes, and lead times are managed and controlled. In order to make these successful, we need to eliminate the sources of problems. So again, within Lean, where we begin to look is to consider which activities add value. So some of the activities we do will change the form of the product, creating a finished article. These are the things that add value. These are the important things we want to focus on and try and minimize the effect of the rest. When we consider the rest, there are some non-value adding activities that are still important to us. So we say they're necessary, but non-value add. So calibrating things, maintaining things, even training, all of the supporting activities we do to enable us to add value are in themselves not adding value, but necessary work. So we need to be understanding of those and make them as effective and as efficient as possible. But then there are some things that don't help any of that, and that's described as waste. And it's been postulated many times over the years. We describe the 7 wastes, things like overproduction, making more than is needed, inventory, having excessive stocks of stuff that needs to be counted and kept in good order, transportation, moving things all over the facility, backwards and forwards. Those are things you'd want to eliminate. Over processing, so we're doing more work than is necessary to meet the specification. And we can have idle time where people wait for processes or processes wait for people. Excessive motion, poor quality. 7 wastes, fairly well established. Key point is we're looking at our processes constantly to identify opportunities to eliminate waste. And then we can focus more attention on adding value. The one that underpins this is the waste of human potential. If we don't inspire people and if we don't engage people, then many of those wastes that are there will go unnoticed because we're not engaging people and we're not getting a flow of ideas. And if we get these things right, then we can truly create flow. And very much the goal of Lean is creating flow. Value should flow. And we have an alternative to flow. which is the batch process. So we've just got a very, very simple illustration here. Doing this virtually, it'll probably be slightly tedious to watch. So I have a simple process. There are 10 dots. Basically, it's one process is a second, and it will move to the next process B, process C. First time we're going to do it as a batch. So we can see process A progressing slowly but surely through the 10 steps. And then once that's complete, moves to the next process. Just about to see a color change taking place. And then we go to the final process, a slight alignment. That would be a quality reject, clearly. And then when that's all done, we have a total elapsed time of 33 seconds. Interestingly as well, obviously it's just a little illustration, but you get everything all at once. That doesn't always suit customers. It depends on the situation. So if we look at this in the situation of flow, single piece flow, kind of the ultimate aim when you're considering flow. Now we simply flow one by one. It's just an illustration, but instantly it looks much more dynamic. And of course it is. And as a result of that, it takes less time, takes about half the time. Interestingly, when you approach a process for the first time and apply some of these lean techniques, that's the order of magnitude you're looking for. Typically, it will halve the end-to-end flow time. And that's all great, providing your processes are reliable. And we know often we have issues around breakdowns, changeovers, things don't work quite as well as they should. So this is where the approaches around total productive maintenance can complement very nicely what we're trying to achieve with lean. So when we think about TPM, total productive maintenance, the goal here is simply the 3 zeros: 0 accidents, 0 defects, 0 breakdowns, and that is achieved through 100% engagement. So the T, similar with lean, is trying to get the total involvement of people in the process. Everybody counts, everybody's ideas count. And if we're respecting people in that way, we get better engagement and motivation. So that's the goal of TPM. TPM is delivered through a series of pillars. There are 8 pillars in total, and each has a specific role and function. This would represent a group of people, a team, if you like, with a common goal. So the focused improvement pillar, this is all about identifying the performance of the process, typically using things like overall equipment effectiveness or various other performance measures. And from that understanding of the process, we're trying to drill down into the data and understand in detail where improvements can be made. And the whole idea with focused improvement is it's at a finite level of focus, so we can actually address problems and make them go away forever. So it's a very structured approach. It's all about solving the problem forever and then confirm it's successful and then pick the next. Autonomous maintenance, this is all about the, if you like, the day-to-day care and control of the equipment and the process. When we're approaching a piece of process for the first time, there may well be restoration needed. So in the early days of implementing autonomous maintenance, it's very much about getting the equipment clean, have a good understanding of the equipment, what are all the minor defects and problems on the equipment, and putting those right. And then once that's in a correct situation, it's doing the shift by shift, day by day checks to make sure everything is clean, in the correct condition, nothing's loose or vibrating, no oil leaks, no air leaks. In other words, we're trying to sustain that optimal condition day by day. Activities typically done by operators, but doesn't always have to be. Planned maintenance pillar, this is looking at a longer interval of control. So typically weekly, monthly, quarterly, annually. And what are the preventative activities that need to be done to ensure breakdowns can be prevented? Now, with all of these pillars, it's really a bit of a journey. There's a number of steps to go through. So within this pillar, it's also considering what's the most critical equipment, what condition is it in, what should our spares strategy be, all of these things, as well as helping the autonomous maintenance pillar to make the improvements they need to make. The next pillar we can see there is training and education. So this is making sure that we don't have any problems through lack of skill. So this, again, team of people focusing on what skills are needed, putting good approaches in place like skills matrices, training needs analysis, building good ways of putting skills across like training centers and providing videos or examples or equipment that people can work on to develop the skills without having the same risk of working online as they learn. And the key point really is those first four pillars very much go together. And when we implement TPM, we would deploy those initially in pilot areas and learn as much as we can from the pilot over 6 months or more. And then when we have a good level of learning and a stable process proven through the metrics, we would then roll out into other areas. So it becomes a very methodical approach. And then there are other pillars that also come as part of total productive maintenance. Very briefly, early management is all about new product introduction or new process introduction, could be new IT systems introduction, but the principle with early management is to learn from the errors of the past and put processes in place to deliver a new product or a process so it's right first time, on cost. Quality maintenance, this is now taking a real focused look on quality, making sure all of the management systems are in place on the one hand, but also looking right in the heart of the process. So we're able to control the inputs and the parameters of a process in such a way that defects do not occur. So it's that real shift from reactive to proactive approaches to quality management. The office pillar, this name isn't always so helpful. This is really referring to all of the supporting processes. So it might be, typically like supply chain activities, for example, all of the supporting processes necessary to get product to flow from the start to the finish of the operation. So this will involve teams of people, again, mapping processes, identifying duplication, errors, sources of misinformation, and developing new processes that are more reliable. And then the final pillar, although really it runs through all of the other pillars, is around safety, health, and environment. So generally now, safety, health, and environment is much higher in the priorities of companies, often good processes and practices in place. So in this sense, it's really looking at the effectiveness and the continuous improvement of the approach to health, safety, and environment. So TPM uses these 8 pillars to try and identify weaknesses or sources of variation in our process that prevent value flowing, and then has structured approaches to make those problems go away. It's also very much about the people, as I mentioned earlier. So the way this is often deployed is through a sort of overlapping group structure. So there may be a steering committee at the sort of leadership level of the organization. There'd be pillar leaders who would also meet and share ideas. So although the diagram looks like we're creating individual pillars, it's very much about collaborative working. And that's what these overlapping groups are really referring to. And this will deploy down through the organization, right down onto, the activity level where teams of people, multifunctional teams are solving problems day by day, week by week. So the organization of this is also key in order to have an effective result. And the reason for this is back to the old iceberg concept, that we may have an equipment failure or a process failure. And that's really the tip of the iceberg. There will have been all manner of things leading up to that are small problems waiting to be discovered, but often easily missed. And the whole idea with TPM is trying to equip people with the skills to recognize problems when they're small and relatively easy to address. What we want to avoid is the build-up of all of these problems until the whole thing falls apart and we have a catastrophic failure. Ideally, we want to recognize it early. If we recognize it early, in fact, we can probably schedule some downtime and put things right before they become a breakdown situation. And you can see the types of things there that are all of these small problems. There might be wear and tear, dirt contamination, damage, cracking, corrosion, all sorts of small things, which if we do not address them, they will ultimately lead to bigger losses. So really at the heart of this, you might wonder why there's a picture of a hole punch there. Normally when we do this as an interactive session, it's quite interesting to just sort of play with some ideas, because a big element of TPM is if we're going to solve a problem, we need to know how that equipment works. And you can take something as simple as a hole punch, and even with something like that, when you really look at it in detail, you can start to see the relationship of the levers and the cams and how the punches operate and how the cutting surface is profiled so it cuts through the paper easily, and even to the point that one punch will advance before the other. So it's a very smooth action to simply put a hole in a piece of paper. And then if you understand that level of equipment function, you can start to think, well, what stops it working? And this is where we start to think about what forces require it to punch and what forces provide a resistance to stop it punching. And simply, if we can understand those things, that will start us to, solve the problem. Is it sharpness? Is it misalignment? Do we have wear and tear on the cams? And we can, by a process of elimination, start to solve the problem in a very methodical way. We can always use fishbone and 5 whys, but this actually gives us a level of a scientific approach to solving a problem. But these things, lean, TPM, these rely on a solid foundation. So again, we're probably familiar with things like 5S, the degree of organization of the workplace. We may begin with hopefully something not quite as bad as this, but nonetheless, there may be materials out of place, tooling and equipment not in fit condition, maybe even evidence of leaks and what have you on machines. So the goal of 5S is to make those problems go away, and it's done in a very methodical manner, again by following a series of steps. And those steps are in Japanese, but obviously the English there on the right-hand side. Step 1 is to sort, which means to segregate what we need, what we don't need. And this is the first opportunity to basically eliminate what we don't need. Can be quite therapeutic, getting rid of what's needed. Then what is needed, we then set in order. So we have a place for everything in its place. And not only that, but it's clearly identified. So the article, if it can be easily moved or lost, that would be identified, and so would its address. It would have a clear place. So it's obvious if it's missing. And then once we have that physical standard established, it's then about maintaining that so things are clean and fit for use. So on a regular basis, say every day, every shift, we're ensuring that that standard is in place, that everything is clean and fit for use. That should give us a basic standard that is repeatable. The standardize is almost making those 3 steps earlier. They're more simple, those 3 earlier steps more simple. So if we find problems when we do the clean and inspect, then we need to eliminate that. So the standardized step is almost the kind of problem solving that we also see in TPM. And then over extended periods of time, what we're trying to do is keep that spirit alive and make it a routine, make it a culture, make it the way people do business. So we follow those 5 steps. And if we follow those 5 steps successfully, we should see a real visual impact, but we should also see some performance and morale impact as well. So we shouldn't be losing things. It should be easy to do a task from one step to the next. And because the environment is more pleasant, it should be a greater motivation for the people involved. Another foundational element here is around standard work. So the whole idea of standard work is to make sure we've got a safe, repeatable, and waste-free way of doing a task, an efficient way of doing a task. But it has to be safe and consistent and easy for the operator. So standard work is trying to work towards this. What we don't want to do is create a standard procedure that is a wasteful way of working. We want to use standard work to eliminate waste and standardize a good process. And this is sort of very much at the heart of the sort of Toyota production system and other approaches as well. Taiichi Ohno, his view was if you didn't have a standard, you couldn't manage anything. So his point was we create a standard and you make it visual. But this is sometimes misunderstood, that visual standard isn't for operators to follow. That visual operators should be trained and know what they're doing. There may be check sheets, but this visual standard is so everyone can instantly see at a glance that things are working correctly. So it's that simplicity and visual standard that helps ensure things are done right. So there is more to it than a standard operating procedure. In fact, there's a number of sheets that we use. There's some examples in a moment, but briefly, time observation sheet. So how long does it take to do what needs to be done? Best known way sheet. If we talk to different people and different people are involved in this, this should always be done as a team, never done two people. So we ask people, what's the best known way? And then we start to build that up as a sequence of steps. What's the correct work content? What's the correct work sequence? This starts to build our standard work. There's a standard worksheet, which allows us to understand the physical world. I'll show you an example. There's a standard operating procedure that allows us to then explain and articulate step 1, step 2, step 3, and not what is done, but also how it's done. And then we think about the fact that there are more steps or more people or more operations. So the line balance bar chart will show multiple people working together to produce a finished product. The standard work combination sheet looks at the combination of activities between a person and a piece of equipment. As we said before, with idle time, we don't want the person waiting for the machine and we don't want the machine waiting for the person. So we look at that combination of effort. And then finally, the process capability sheet, capacity sheet rather, is looking at do we have enough equipment and machines to do the job. These slides can be made available. It's not so readable on this screen anyway, but each of these forms has a standard sheet to follow. So standard work layout, standard operating procedure, combination sheet, and capacity sheet. Bar chart so we can see if the line is balanced or imbalanced. And then finally, as we come to draw this to a close, just generally when we start to think about solving problems, very often we solve problems that don't need to be solved. The first question actually is, do we have a standard, just as we were describing? So if we, encountering a problem in the workplace, our first question should be, do we have a standard? Is it being followed? Does it work? And if any of those answers are no, then that's where we begin. We don't need to get into root cause. We need to please work to standard. Now, if we find we work to standard and we still have problems, that's when we need to get into that improvement loop on the right-hand side. So this is where root cause analysis is important. And that will then drive a new standard. Once we've got a new standard, we're back on the left-hand side. So this infinity loop is a good way to manage the problem solving and the continuous improvement. Okay, so just drawing to a close, where to begin with all of these things. There are different ways of approaching improvement. I've named a couple. Lean and TPM are good, solid approaches. Key thing is be committed to the program. Leadership commitment, leading by example cannot be overemphasized. It's also a good strategy to begin with pilots. So focus in specific areas, not trying to do everything all at once. And then you can really deliberately learn from the pilots and then apply that learning elsewhere. These things will take time and effort, so resource and time need to be required. And then follow the approach, follow that systematic approach. And once all of those things can be built into a master plan, then it can be governed and managed over time. And if problems occur, the countermeasures can be developed. So very briefly, that's a kind of quick run through Lean, TPM, transforming things, and some of the foundations. It is possible to find out more. There are some courses available if people are interested around TPM, specifically around the relevance with IATF, and also same for standard work. So that concludes my presentation. I'll happily take some questions.
Can you hear me?
I can hear you, yes.
Okay, Simon, thank you again for your smart and enlightenment about these two subjects related with standard work and with TPM. It's always a pleasure to hear your clear explanation about all these subjects.
Thank you.
I have here a couple of questions that our viewers send us. Let me try to start with the hard one. So how do you see this kind of training providing on the as VSCM online? Okay, nowadays, as you know, we have some problems on being in the in plant. Yeah. So how do you see this kind of training when we are trying to deliver this training online?
Yeah, well, we've got some experiences of that recently because we've had to. Now, the way that we've done it is really through a series of virtual workshops. So the trainer or the coach can guide people. There's an element of training, and the theory is the theory. But when it comes to actually creating value stream maps, the way you can do it is first of all get people to either do a video of the process end to end, or even a storyboard map with photographs end to end, and that can give a visible image of the process from start to finish. Once everybody is looking at the same picture virtually, but at least on the same picture, then it's possible to coach people through, right, we can now see literally whether it's a photograph, and we can even do it on a wall, still do it on a wall. We can see the picture of the step one, picture of step two, picture of step three, and then we can coach people through what are the process parameters of step one, what's the cycle time, what's the OEE, what's the changeover times, then in between the operations, what's the inventory, what's the delay, and basically we just build the picture up, providing there's a reasonable, connection, and providing, again, as always, we've got the right people in the room. We just work through it, because sometimes the alternative is, we wait, and waiting isn't always an option. So it can absolutely be done. There are, I think, some software. We also use packages like GoToTraining, so you can get virtual whiteboards. But we can do it just with Zoom. If there's a space, we can point the camera. We might need to share documents. There is a way of doing it. It's limited only by our own imagination.
Okay, thank you. So the other question I have for you is if you can make a comment on the application of the VSM to services, not in manufacturing, not in a production area, but in services.
Yeah, and basically it works the same. What helps slightly in services, instead of making it, if you like, a single horizontal line from process one to process two to process three, in services, more commonly, you have different departments involved.
Yeah.
So the way to do that is described as swim lane mapping. So, for example, instead of that one, physical flow, you might have one channel which is around the customer interface, customer services, order receipt. There might be another one which is around procurement, so they would have a swim lane. there might be one about engineering or technical. And basically, each discipline has its swim lane. And once you've got that, if you like, discipline and imagery, you basically follow each swim lane from left to right. And often with transactional and service type processes, you'll see a lot of transactions going between the different departments. And this becomes interesting because the more of those zigzags, the more there is a risk of error and time delay. So you're literally trying to make that as smooth a flow as possible, not just left to right, but also up and down between the swim lanes.
Okay. So just put it in another words, just to make clear, it's not only applicable on manufacturing and production, it's also applicable on all service areas and transactional areas.
Absolutely.
Okay.
Absolutely, yes.
Because sometimes there is some misunderstanding about this tool. So just to make clear for everybody that this is applicable on many areas, not only manufacturing ones.
Yes, for sure.
Okay. So the other question I have here for you is how do you see the TPM and on all others Japanese methodologies, and how do they interface with the IATF 16949?
Yeah, I mean 16949 is a holistic approach. It's trying to make businesses healthy, top to bottom, end to end. Total productive maintenance is trying to do the same. Lean is trying to do the same. So I think it's looking for that. It's really looking for the areas of harmony, not the areas of conflict. The goal is the same. 16949 has clear approaches, and I think there are opportunities to, it's really in the how to. So what to do, the standard can define. How to do it, well, we can pull on some of the approaches from Lean and TPM in terms of the how to. Yeah. I think that's really the best relationship because the goals are the same.
Okay. So the last one for you, in your opinion, why do you think we have such a resistance from some companies on the implementation of the TPM program? Because it has such a good benefit for those companies, why do you think we still have some resistance on the implementation of these programs?
I think sometimes we think it's too simple, and maybe the language doesn't help, because if we think of it as productive, the words productive and the words maintenance make us think it's just what the maintenance people do in the factory. But that's a misunderstanding. It is more holistic. So there's more to it than that. It needs more effort than that. Which means it's harder. So I think sometimes we sort of fall into the trap of thinking these things are easy and it'll be an overnight success, when actually, we have to work harder at it than that. And I think sometimes we don't have the appetite for it, but truly the benefits are there. You can get huge improvements in performance by doing these things properly. But if we only half do them, it will fall back. And that's often the frustration. Yeah.
Because sometimes they misunderstand this TPM program with only maintenance.
Correct.
Okay.
Yes.
It is much wider than maintenance only.
Absolutely. Yes.
Okay, Simon. Thank you very much again for your presentation. It's always nice to see you and hear you.
Well, thank you. Same.
Soon.
See you again.
And thank you very much. And
yeah.
Bye-bye now.
Thank you. Bye-bye.
Bye. Thank you.
Bye.